In the first exercise, we're asked to determine the range, okay? So really the range is just the minimum to the maximum. So who thinks they can tell me already on A? What's the range? What's the minimum maybe? Let's start there. The minimum, Connor? -3. Anybody think something different? Do we all agree? How'd you get that, Connor? 7 from the 4. Yeah, correct. So your midline's at 4, and then you're going to go down 7 from 4. So that's going to bring you to a minimum of -3. And the maximum? Going to do that? 11. Very good. Your midline of 4, and then you're going to go up 7 from there. And that's your range. Your midline minus your amplitude, and then your midline plus your amplitude. So Aiden, what do you think your minimum is going to be in part B? Good, that's your midline of 2, and then you got to go down your amplitude of 5, so 2, and then down 5 puts you at -3. And then 2 and up 5, Aiden, brings you to 7. And part C, Maddie, what do you think for your minimum? Yes, 35 is your midline. Go down 25, you're at 10. And your maximum, Kaylee's here. 35 plus 25? Correct. Okay? So just, they can ask you for the range. I think that might have come up last week. 7's asking sort of the same thing, but it's presented differently. It kind of presents as being a totally different type of question, but yet the concept that they're testing is the same. Which of the following lines, when drawn, would not intersect the graph of y equals 6 sine x? What is the maximum of this? 6. And the minimum? -6. So your midline is 0. There's a plus 0. So your range is from -6 to 6. Goes down 6 and up 6 from 0. So which of these would not intersect the graph? Now, if you look at your two types of equations, what kind of lines are these? Vertical. What do you know about sine and cosine graphs and vertical lines? What'd you say? Yeah, the sine and cosine graphs go on forever. So no matter where you put a vertical line, it's going to touch it. So these kind of are tripping you up because they're giving you vertical lines. These will intersect the graph somewhere. Your y lines are horizontal. Will the y equals -4 hit this? Yes. Okay, -6 is down here somewhere. Of course -4 is going to hit it. Will y equals 9 hit it? No, because the max is at 6 and 9 is way above the graph. So this one will not intersect. Same concept, totally different way of asking it. Okay? Number 3, they're asking you for the range. Take a minute. And then on the count of 3, hold up 1, 2, 3, 4. 1, 2, 3. I see mostly, if not all, 2s, which is correct. What mistake did they try to trip you up with, Maggie? Yeah, parentheses. And the reality is we actually reach the minimum, right? It's not like it's an open circle there or anything. So a bracket, -77. Which of the following is the period of y equals cosine x? Take a minute, think about that. And then on the count of 3. Hold up 1, 2, 3, or 4. 1, 2, 3. I see a lot of 3s, if not all 3s, which is correct. Couple things. Number 1, this is like a fact. You should just know it. Sine curves and cosine curves, parent graphs, have a period of 2 pi. That's how long it takes things to repeat. And on day 1 of this, we talked about the reason was because we're going around the unit circle. We're doing 1 pi over 6, 1 pi over 4, 1 pi over 3, pi over 2. And then we do 2 pi over 3. And 3 pi over 4. And we go around, and this whole thing, the cycle starts repeating once you get one full 2 pi around the circle. So the parent graphs just have a period of 2 pi. That's a fact. You should just know that. If you're kind of in machine mode, which I think we are, how many of you did period equals 2 pi over b, and we know b is 1? How many, raise your hand if you did it that way. Yeah, okay. Raise your hand if you did it just, it's a fact and you knew it. Okay. A little more of a mixture than I thought. But the answer there is 2 pi. Okay, take a minute, try number 6. John, what do you think? Option 2, did anyone think anything different? Maggie, what do you think? 3? Does anybody think anything different? Okay, so we're between 2 and 3. So we are at, what are we given here, John? Right, if they tell us that high tides are separated by 24 hours, they're giving us the period. So period equals 2 pi over b. And if you know 24 is the period, we just plug it in and solve for b. So put that 24 over 1, cross multiply, 24b equals 2 pi, and divide by 24 because we're solving for b. And b equals the 2 over 24 reduces to pi over 12, so our answer is 3. Any questions on that one? Okay. Take a minute, think about number 5. Cameron, what do you think? So 3 sine. Is there a phase shift? Well, if you look at your options, none of them have a phase shift. None of them have a midline other than zeros. They're all the same 0. They're all the same amplitude of 3. So given that there's no phase shift on any of them, the cycle's definitely starting on the y-axis. So starting here and ending here. So to you, that's a positive sine curve. Negative, it's not a sine curve, right? Sine curves start and end on a midline. Look up there, they either do that, that's a positive sine, or a negative sine. So this is a cosine curve, yes? So 3 and 4 are actually out, and is it a positive cosine or a negative cosine, Mason? Minimum to minimum is a negative. Remember, positive cosines are max to max, negative cosines are min to min. So this is a negative cosine, which would be option 2. Okay. Number 6. Cameron, I'm going to let you totally redeem yourself. Take a minute, though. I know we just looked at it. What did you say? Is it 3? Raise your hand if you think it's 3. Oh, you got a lot of supporters. It is. So none of these have a phase shift either. So the cycle starts here, ends here, and it's a positive sign. Everything else is the same. These are just really solidifying if you can pick out which one it is. And truthfully, what's confusing about this is I could write this as a negative sign. I could start my cycle back here, but that would require a phase shift in the equation, yes? And none of these have a phase shift. I could treat this as a positive cosine if I looked at that section, but that would require a phase shift 3 pi over 2 units to the left. Or I could look at it as a negative cosine graph, but that would require a phase shift pi over 2 units to the left. So that's why it's confusing in some ways with a multiple choice, because they can be written as any, but given that there's no phase shift, you've got to start your cycle right at the y-axis. All right, this one's a tricky, again, concept we've done, no problem. Presentation, a little bit different. So when the period of a cosine is divided in half, what happens to the frequency? The frequency is really the number of, in this context, and the context can change, the frequency is the number of cycles that get completed between 0 and 2 pi. So if it's just a traditional graph, there's one cycle between 0 and 2 pi, because that's what the period is. If the period gets divided in half, and I guess we're dealing with a cosine, so there's your traditional cosine curve. If that gets divided in half, that period, so rather than being 2 pi, we're going to complete our cycle by 1 pi. How many cycles will I now get in before 2 pi, Maggie? 2. So what happened to the frequency? It doubled. Very good. So think about this from an algebraic perspective. Period equals 2 pi over b. So right now, if I solve for b, put this over 1, I get pb equals 2 pi, and I divide both sides by p. The frequency is 2 pi over p. But if it's telling me what happens when the period is divided in half, so if I take that period and cut it in half, so divide it by 2, and then solve for b, I'm going to get bp equals 4 pi. Solving for b, divide both sides by p, I'm going to get that b equals 4 pi over p. So here's my b originally, and then what happened to my b? I doubled it. 2 pi over p doubled to 4 pi over p. So your answer would be it doubled. And the last piece here is just giving a little bit more detail on frequency. So the frequency of a function is the number of cycles that are completed along the interval from 0 to 2 pi. Observe the graph of this on your calculator. So let me and what mode should we always be in? I'm going to say it says on the interval from 0 to 2 pi. And the amplitude of this function is what? Or what's the max to min, I guess? Negative 1 to 1. It's there is no vertical stretch or vertical shift of any sort. So it's negative 1 to 1. So observe this. There's the first sine cycle, and now it's starting a second sine cycle, yes? Okay? So how many cycles of sine fit in the interval from 0 to 2 pi? Here's our first, ends there, and here's our second. So 2 cycles fit. And the value of b from the function is 2, hence the reason why b is our frequency. Now this gets a little bit tricky. Think about this example. Our b is not a whole number there. Our b is pi over 2, which means our frequency is 1.57. That means 1.5 cycles fits in by 2 pi in a case like that. And when full cycles aren't fitting in, it gets tricky to think about frequency in that way. But if that's your frequency, that means 1.57 cycles fits in between 0 and 2 pi, which hopefully you won't ever be asked to think about it from that perspective. How about this? Andy, will you hand out a homework to everybody? You'll have plenty of extras. And I'll pass back your tests, your first